Welcome to the deep dive. Today, we're really getting into the weeds with a specific source.
Yeah, we've got a Jupyter notebook here, SK03 essentialsfilters.ypime.
Exactly. And we're going to pull out the key ideas about, well, a really powerful feature, semantic kernel filters.
It's a great notebook because it's so practical. It shows you, step by step, how to set up content filtering.
But it's more than just that one example, right? It demonstrates this broader concept of control.
Absolutely. How filters let you really manage and, modify what your AI applications are doing.
Right. So our mission today, yours and mine, and for you listening, is to look at these steps and really understand the practical side. Why are filters so crucial for building AI that's, well, smart and safe?
Couldn't have said it better. Let's jump in.
Okay, so where does the notebook kick things off? The environment setup.
Yep, standard Python stuff, mostly.
Yeah.
Getting the groundwork laid.
You see those imports at the top? Asyncio, yeah, that makes sense. Semantic kernel does a lot asynchronously.
Right, and logging, super useful for debugging later,
Right.
especially with filters out for environment variables.
Yeah, pulling in API keys and secrets that way. Always good practice. Keeps them out of the code.
Definitely. But the key ones for us today are from Semantic Kernel itself. You've got the kernel,
The core orchestrator.
kernel function for wrapping our Python code, then the connector, like Azure Chat Completion here,
Right. The link to the actual LLM.
and chat history, obviously.
Mm-hmm.
But then the big ones, filter types and function invocation context.
Ah, okay. Those names alone kind of signal we're dealing with interception, right? Modifying the flow.
Exactly. That function invocation context holds all the info about a function call as it's happening, and filter types tells the kernel when to run our filter.
Got it. So imports are done. Then it connects to the AI service.
Yeah, pretty standard setup again if you've worked with SK before. Initialize the kernel object.
And then add the service, like the Azure Chat Completion, pointing it to your deployment using those environment variables.
Right. It's basically hooking the kernel's brain, the LLM, up to the system.
Okay. Foundation laid, intelligence connected. The notebook mentions basic logging too.
Yeah, just setting up some simple logging output, which, believe me, you'll want when you start adding custom filter logic and need to see what's actually firing.
Makes sense. Okay, so basics are covered. Now, the really interesting part, defining the filter itself, this content blocking filter.
Right. This is the core of the notebook's example. It's just an async Python function. You could name it anything, really.
But its job is key. It acts as a kind of gatekeeper.
Precisely.
Yeah.
It sits there, and when a function invocation comes through, this filter gets a look at it before the actual function or the LLM does.
And the logic in the notebook is pretty straightforward, right? It looks for a specific word.
Yeah, super simple for the demo. It checks the user's input string for the word bad word. Obviously, in a real app, this could be much more complex, a list of words, maybe a call to a content moderation service,
Sure, but for understanding the mechanism, bad word works. So if it finds bad word, what happens then?
It stops everything. It blocks that function invocation from going any further.
So the request doesn't reach the plugin's chat method or the LLM at all.
Nope. Dead stop. And instead of just silently failing, the filter actually takes control of the response.
Ah, so it crafts its own reply.
Exactly.
Yeah.
It creates a chat message content object with a specific message, like the notebook uses. I cannot process requests containing prohibited words. Please try again.
Okay, that's clear feedback to the user.
And crucially, it adds a little flag in the metadata. Filtered.
True.
Why is that important? So that later, your application code can check that metadata and know, this response didn't come from the AI, it came from my safety filter. It helps with logging, metrics, or even just displaying things differently to the user. Transparency.
Got it. So that's the blocking path. What if the input is clean, no bad word?
Then the filter's job is basically to just get out of the way.
How does it do that?
It calls await next context. This is super important.
Okay, next context. What does that do?
It passes the control flow baton. It tells the semantic kernel pipeline, okay, I'm done. Let the next thing in line run. That could be another filter if you have multiple chained together, or if there are no more filters, it allows the original function invocation, the one that was intercepted, to finally proceed.
Right, so it's like saying, checked it, it's okay, carry on.
Exactly. Without that next context call, even clean requests would just stop at the filter.
Makes sense. So you define this function, this gatekeeper logic. How do you tell the kernel, hey, use this?
You register it with the kernel. The notebook uses kernel.addFilter.
And you associate it with that filter types, talking invocation you mentioned earlier.
Correct. That tells the kernel, Run this content blocking filter function before any function invocation happens anywhere in the kernel.
Wow. Okay, so it's a global hook, basically.
It can be, yes.
Mm-hmm.
You can get more granular, but for this example, it applies everywhere. It's a really powerful way to inject cross-cutting logic without touching every single plugin function.
Okay, filter defined and registered. But now we need something to filter, right? The notebook sets up a simple plugin for that.
Yep, exactly. A basic chat plugin class.
With just a chat method inside.
And that chat method is pretty standard semantic kernel stuff. It takes the chat history, takes the new user input,
Adds the new input to the history.
and then calls the kernel's chat completion service, the one we hooked up earlier, to get the LLM to generate a response based on that conversation.
Just a standard chat interaction pattern.
Right. And then, of course, you add an instance of this chat plugin to the kernel, so the chat function is actually available to be called.
And, crucially, available to be intercepted by our filter.
Precisely. Now all the pieces are in place for the demo.
So the notebook then shows this in action. It sets up some test cases.
Yeah, a little list of strings. Some contain bad words, some are just normal questions or statements.
And it runs them through the chat function.
Right. It iterates through the list, calls kernel.invoke, chat input, user input, for each one, basically simulating different user requests.
And the output shows the difference clearly.
Very clearly. When the input has bad word, you see the log message from the filter, something like filter action, detected forbidden word, bad word, blocking function invocation.
And no response from the LLM itself.
None. Instead, you get that custom message the filter generated. I cannot process requests containing prohibited words.
Proving the filter did its job.
Exactly. And for the clean inputs, you see the filter's other log message, filter action, no forbidden word found, proceeding.
And then you see a response.
Yep, then you get a typical chat response generated by the actual Azure OpenAI model that was configured.
So it's a perfect illustration. Filter intercepts, checks, blocks, or allows.
It really drives home how you insert that control layer right into the pipeline before the potentially expensive or sensitive LLM call happens.
And like you said, this content filtering is really just one application, isn't it? This filter mechanism seems way more flexible.
Oh, absolutely. It's just the tip of the iceberg. You could use this same function invocation filter type for so many things.
Like what?
Well, detailed logging or telemetry, capturing exactly what functions are called, with what arguments, how long they take. You could do more sophisticated input validation, maybe checking against a database or an allow list.
I see. What about modifying things?
You could potentially modify the arguments before they go into the function. Or you could use output filters. Filter types.prompt trending or filter types. Function result to inspect or even change what comes back from the LLM.
Ah, okay, so filtering on the way in and on the way out.
Exactly. Maybe parsing structured data from the LLM's response, or ensuring the output adheres to certain formatting rules, or even doing things like dynamic routing, deciding based on the input which function should actually handle the request.
Wow. Okay, that really opens up a lot of possibilities for building complex, reliable AI systems.
It really does. Filters are fundamental to moving beyond simple prompt response and into building truly engineered AI applications with semantic kernel. They give you that fine-grained control.
Right. So let's quickly recap the journey through that notebook then.
Sounds good.
We started with the basics. Setting up the Python environment, importing the necessary bits from semantic kernel, including those key filter types.
And connecting the kernel to the AI model, the Azure OpenAI service in this case. Getting the core plumbing working.
And then the main event. Defining that custom content blocking filter. Understanding its async nature, the logic inside checking for bad word.
And the critical actions. Blocking the invocation if the word is found, crafting that custom chat message content response with the filtered, true metadata.
And importantly, using a wait next context to let clean requests pass through the pipeline smoothly.
We saw how kernel.addFilter registers this function to run before function invocations.
And then we needed something to filter, so we saw the simple chat plugin being set up and added.
Finally, the demo brought it all together, showing clear output differences between blocked requests, with the filter's custom message, and allowed requests, which got a normal LLM response.
Yeah, it really illustrated the filter intercepting things perfectly.
And the big takeaway, really, is that getting comfortable with filters is key. It's how you build responsible, secure, and highly tailored AI solutions using semantic kernel. It's about governance.
It gives you the power to shape the behavior in a very direct way.
Exactly.
Okay, well, that wraps up this deep dive into semantic kernel filters based on that excellent notebook example. Thanks for walking through it with me.
My pleasure. It's a powerful concept.
It really is. And, here's a thought maybe to leave you, the listener, with. We focused on a filter acting before the function call, blocking bad input.
Mm-hmm. Pre-processing.
Right. But think about using filters after the LLM has done its work. Could you use an output filter to, say, check if the AI's response accidentally included sensitive information? Or maybe even automatically tweak the tone to better match a specific brand voice before the user ever sees it?
Ooh, interesting. Like a final quality check or a stylistic adjustment layer.
Exactly. Lots to think about there.
Definitely.
So what's next? The notebook series kind of hints at it.
Yeah, the next logical step is observability. Now that you can build these complex flows with filters and plugins, how do you actually monitor them? How do you see what's going on inside?
Crucial for debugging, performance tuning, understanding real-world usage.
You got it.
Yeah.
So that's what we'll likely dive into next time.
Looking forward to it. Thanks again.
Catch you then.
We'll catch you next time.